In today's lesson, we'll be learning how to apply the slope, midpoint, and length formulas. In our first example, the vertices of triangle ABC are provided. We need to determine whether triangle ABC is a right triangle. As you can see, coordinates A, B, and C have already been plotted. If you remember, a right triangle has a 90-degree angle. Now, when you're talking about a 90-degree angle, you can verify that using the slope equation. Now, how are their slopes going to be related? Well, they're going to be something we call negative reciprocals. It is important to make a rough sketch because you can likely spot the 90-degree angle already. The 90-degree angle is likely located over here, but we are still going to determine the other slopes and compare them just to be safe. As mentioned before, just to be safe, I'm going to calculate the slope of each side. Let's start with side AB. I'm going to arbitrarily call this point 1, and I'm arbitrarily going to call this point 2. We're going to begin with our slope equation, and I'm going to write a little subscript to indicate which side I'm calculating. So that's side AB. Next, I'm going to substitute in my known values. So instead of y2, I'm going to put in -1. And instead of y1, I'm going to put in +5. Instead of x2, I'm going to put in -3. And instead of x1, I'm going to put in +5. We're going to have to simplify in this next step. -1 subtract 5 is -6. And -3 subtract 5 is -8. When you have a negative number divided by a negative number, that becomes positive. And if you simplify this, this is going to become 3/4. Therefore, the slope of line segment AB is 3/4. We're going to do the exact same thing again, except we're going to find the slope of line segment AC. I'm going to call that point 1, and I'm going to call this point 2. We're going to start with the slope equation, and I'm going to use the subscript of AC, since that's the line segment I'm dealing with at the moment. Next, I'm going to substitute in my variables. So instead of y2, I'm going to put -3, and instead of y1, I'm going to put +5. Instead of x2, I'm going to put +1, and instead of x1, I'm going to put +5. We're going to simplify in this next step. -3 subtract 5 is -8, and 1 subtract 5 is -4. A negative divided by a negative becomes positive, so that becomes 8/4, and 8/4 simplifies to just 2. Therefore, the slope of line segment AC is 2. We're going to do the exact same thing for the slope of line segment BC. I'm going to call point B point 1, and I'm going to call point C point 2. We're going to start with the slope equation, and I'm going to use the subscript of BC to indicate which line segment I'm dealing with. At this point, we're going to substitute in our known values. So y2 is going to be replaced with -3 in brackets, and y1 is going to be replaced with -1 in brackets. x2 is going to be replaced with +1 in brackets, and x1 is going to be replaced with -3 in brackets. We're going to have to simplify in this next step. So -3 subtract -1 is the same thing as -3 plus 1, which is equal to -2, and 1 subtract -3 is the same thing as 1 plus 3, which is 4. -2/4 can be reduced, and that can be reduced to -1/2. Therefore, the slope for line segment BC is -1/2. Let's summarize our results by labeling our diagram. We determine the slope of line segment AB to be 3/4. We also determine the slope of line segment BC to be -1/2. And last but not least, we determined the slope of line segment AC to be 2. So as you can see, our suspicion has been confirmed, and that there is a right angle located over here. Let's end this off with a concluding statement. Since the slope of BC and AC are negative reciprocals, therefore, triangle ABC is a right triangle.